You circled that?
Yeah.
Why?
Explain these as sides. I don't know. That's
well, okay. Here's the thing, and I've said this before to you. When you have the distance between 2 points, what you're really looking at is the hypotenuse of a triangle that you would draw, right? In other words, if I want the distance between that point and that point, the triangle doesn't exist until I draw it in. Now you've labeled this side as y squared. Not really true. That side is x, first of all. And this side is y. And this side is z, which is equal to the square root of x squared plus y squared. Let's talk about that for a minute. If I have a point here that's 5, 6, and I have a point over here that is 3, 1, okay? That distance you can think of as the hypotenuse of a triangle that you would draw. Okay, let's call that z. What is this? That's delta y, right? The changes in the y-coordinate. Here, let me erase this where I've labeled it so I can put it in a better place. In other words, I use this terminology delta y, and I don't normally use that with geometry students, but I happen to notice in your problem that you had the z labeled as delta z. Okay, this would be delta x. What is delta y? Delta y is the bigger coordinate minus the smaller coordinate. What is delta x? It's the bigger coordinate minus the smaller coordinate. So in my example, what is delta y?
Delta y is delta x.
No, what is delta y? Put a number on it. Plug in y sub 2 minus y sub 1.
Minus y sub... 1 minus -5.
No. This is x sub 2, y sub 2. This is x sub 1,
so then 6 minus 5.
y sub 1. No.
Wait, what?
Changes in the y coordinates. That's all you need is what is the difference in the y coordinates.
So 6 minus 1 is 5.
Okay. That's what I was looking for. What's the difference in the x coordinates?
2.
Okay. And I don't really care whether they're positive or negative. Why? Because my distance formula is the square root of delta x squared plus delta y squared. So in this case, delta x squared is 4, delta y squared is 25. My square root would be the square root of 29. That would be the distance between this point and this point. And you'll notice that that is the exact formula for the hypotenuse of a right triangle. And this is always a right triangle if I've dropped a dotted line vertically. In other words, if you apply Pythagorean's theorem to that, you get z squared equals delta x squared plus delta y squared, which means z is equal to the square root of delta x squared plus delta y squared, which means z is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay, but if you remember that, you can always get to the final formula. The key is to remember what the distance between 2 points is. It is the hypotenuse of a right triangle. And once you realize that, you'll always be able to come up with the answer. Now, let's see exactly what happened here. Okay. So, you labeled that y squared. Well, that's not really y squared. It's not y. That's x, right? And that's x sub 2 minus x sub 1. This side over here is y sub 2 minus y sub 1. I guess the reason she wanted you to explain that is that these are the two short sides of the right triangle that you would get if you create it. I thought your explanation was actually pretty good. I'm surprised she took a point off. But this is correct. Oh, I see what's happening now. That's not delta z, that's d squared. So, it's true that d squared equals x squared plus y squared, but the reason she asked what are x and y, because x is the difference in the x coordinates, and y is the difference in the y coordinates. All right, let's look at the second one. Determine the area What's the area of the triangle? If you've got it right, if this is 4 root 2 and this is 4 root 2, what's the area of the triangle? What's the general equation for the area of a triangle?
1/2 base times height.
Okay, well this is base times height.
So I have to divide by 2.
Yeah. And it looks like maybe you multiplied. Oh, I don't like that equation right there. You got 16 root 4 equals 32, which is a correct statement, but it's not equal to 32 root 2. In other words, if you're going to pull that 2 out of there, then it's 2 times 16. So 16 root 4 would equal 32. But it's not equal to 32 times root 2. Alright, let me look at the next page. Alright, what kind of triangle is the triangle they drew?
An isosceles. Oh no, an equilateral.
Equilateral, exactly. And they suggested we call that 2x. Well, that makes that 2x and this 2x. But to create the 30, 60, 90 triangle, I got to drop a vertical here. Okay? This is still 60. This now becomes 30. This is the 90. What's the measurement from there to there?
X.
Yeah, it's half of 2x. So now I have this 30-60 triangle whose measurements are 2x and x. Well, use Pythagorean's theorem to come up with this. It's a right triangle.
Well, can I just do x squared like 3?
Okay, when you're given a right triangle to solve, which we have right here, and we have two sides of it, the third side is equal to what? Let's call that z. What is z equal to?
X times the square root of 3.
No, it's the square root of the hypotenuse squared minus the other short side squared. In other words, if you can remember these formulas for solving for the third side of a right triangle, it will save you tons of time. You don't want to always have to go back to the Pythagorean theorem. In other words, if they give you a right triangle and they give you the hypotenuse and they give you one of the short sides, then this is the equation. If they give you both short sides, then the equation is the square root of the square of both short sides. Okay? So if we solve this equation, what do we get?
Two x or 4x squared minus 2x squared.
Minus x squared.
Yep.
It's 3x squared. Well, the x comes out. So it's x root 3 or root 3x. So that is the side z, is root 3x. Now, the only point of having an x in there is because when we're talking 30-60 right triangles, we're talking all multiples of them. I actually prefer to teach this by teaching what I call the unit 30-60. And the unit 30-60 is 1 opposite the short side, square root of 3 opposite the 60-degree angle, and 2 as the hypotenuse. Notice that's the same thing. Is all this triangle is a multiple of this triangle. What multiple? Whatever you want it to be. It can be twice, 3 times, 4 times, does not matter. As long as you have a 30-60 right triangle, it's the relationship of the sides to one another that matters. I don't even know what she wants for an answer here. I can't deal with questions like this. Or
I have the same. I did.
This hand sack?
Yeah, Anzac.
Really? This is a question he gives you to review for your final?
Well, this is on a previous quiz. He told us to look at the past 10 quizzes and look at the complex answer ones, which is the last 2 or 3.
Okay. I honestly think you'd be better off reviewing the material I got from other teachers. I cannot think of a worse review material than you just got from ANZAC. I mean, I hate to be brutally frank, but this is a terrible way to review for your geometry final.
I know, but on Monday he's giving us 2 finals. The first one, which is Monday, is about like all these complex ideas that we have to understand from each unit, and then the second one is the actual, like,
Okay.
postulate theorems, whatever.
You can, in the law of sines, you cannot have a triangle that is angle, angle, angle. Not sure what that means. The law of sines is setting up ratio to find your missing part, but that you need for one side to set up the equation, you need one side to multiply out. Okay. I'll take my best shot at this problem. You obviously cannot use the law of sines on side, side, side. Why?
Because you need an angle, an angle to determine.
Yes. You have to have an opposite angle side relationship. So as long as I had an angle over here, 50 degrees, now I can solve that triangle because I have a side opposite angle relationship. And I know that the sine of 50 degrees divided by 6 has to be the sine of theta divided by 7. And then I do the same for the third angle, and I can figure out all three sides and all three angles. The other situation that you cannot use law of sines on is side angle side. In other words, if this one's 6 and that one's 7 and this is 50 degrees, I do not have an opposite side angle relationship. So I can't even begin by using the law of sines. So these are the only two situations, side, 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 and side angle side, where you cannot begin the problem using the law of sines, and you have to solve both of those by using the law of cosines to start. Now, even every triangle that you would use the law of cosines, you end up using the law of sines as step 2. But you have to use the law of cosines in step 1. Okay? Angle, side angle. Well, notice that if I know that's 50 degrees, and I know that's 60 degrees, and I know this side is 7, I really know this angle here also. In other words, this has to be 70 degrees, and now I have the angle opposite side relationship, and I can proceed to solve the problem. So I can solve the angle side angle problems completely with the law of sines. But I can't with side angle side problems. Now, it turns out that there's a third category, side side angle problems, like this, where say that's 70 degrees, that's 10, and that's 8. That is side side angle, or angle side side, however you prefer. But the order is side side angle, and you can use the law of sines to solve that. Although this is the one ambiguous case. Did you ever cover the ambiguous case of the law of sines? Quade?
Yeah, we did.
You did. Okay. Well, this is the only time you have to worry about it, is when you have side side angle. And then there's a very special technique that you have to use to discover whether you have the ambiguous case or not. Notice what the ambiguous case would look like. That's still 70 degrees, that's still 10, and that's 8. But if I told you that you had a triangle that had a 70-degree angle followed by a side of 10 followed by a side of 8, it actually could produce either one of these triangles, and that's why it's called the ambiguous case. because when I give you those three measurements, it doesn't refer to precisely one triangle. There are two triangles that can be drawn. And that really is the only difficult part of the law of sines. Every law of sines problem is first grade algebra level, except the ambiguous case of the law of sines. And that requires a lot more study, some knowledge of trig, and a couple of other things. And if you like, we can certainly cover the ambiguous case of the law of sines next time. But, I don't like this review material. I'm never going to like it. I hate review material where they want you to explain stuff in English. That's not mathematics. Mathematics is solving problems, graphical problems, or coming up with numbers, not coming up with paragraphs describing why you can't use the law of sines on this. I don't know what to tell you. I understand you're doing exactly what your teacher is requesting. I'm just saying it sucks.
I agree.
And I don't care if you tell them. You can tell them. I think that this is the worst review material I have seen for a geometry final. I have some really good review material that I think it would behoove you to let me show you. And it's going to involve you knowing all of the proper general equations. And when I say all of them, I'll bet there's 50 of them. Don't you think there's 50 general equations in geometry? When you talk about volumes and surface areas and quadrilaterals and circles and chords and secant lines and tangent lines, I'll bet you there's 50 equations. And the problem that I'm discovering, and I just recently discovered it, is that students doing their homework at home have their book open and they're always looking at those equations and they're able to solve the problems. But then you go to take a test and you forget what the general equation is. So the primary difficulty, I now believe, with people taking tests is they don't remember the general equations. So if you want to memorize anything, go through all of your general equations. And the review material I have is exactly that. Every problem is different. Every problem requires a different general equation that you have to start with. Okay?
Okay.
We have a session on Sunday at 4.
No. It changed.
It changed?
I think so. My mom changed it.
To when?
To 7:30. I think 7:30.
I don't have a 7:30 available. She couldn't have changed it to that. In other words, I'm scheduled from 6:30 to 8:30 that night. She probably tried to change it, but she couldn't. Do you want to change it? Does 4 not work?
Well, yeah. Because I won't even be home until like 4:30.
Okay. So let's pick another time. You want to do 5?
Yeah, that's fine.
All right. Let me move it to 5.
Okay, perfect.
Okay. I'll talk to you then. And yeah, be thinking about what you want to cover. I know it's problematic for you because of what your teacher said, but that's just awful. That's just terrible what he told you. All right. Wade, I will talk to you Sunday at 5.
All right, bye-bye, thanks.